let's take a few minutes. We'll use third period's data and we'll review how to calculate probabilities from a two-way table. So we had males and females shoot paperwads at our blue bins in the classroom. And in third period, there were 60 shots taken by males, 74 by females, so that's a total of 134 shots. 46 of them were hits and 88 were misses. So a basic probability, what I would call a plain probability, the probability of a hit. So this is not a probability that uses the term or the term and. It's not a conditional probability. We're just looking at the event hit the basket. So that event happened 46 times out of 134 trials. So the probability is 46 out of 134. So an and probability, hit the basket and the shot was taken by a female. And is often represented with this symbol. Looks like an upside down U. It represents intersect. So I'm looking for the event where I have hits and the shots are taken by females. So you're looking for the intersection of the female column and the hit row. So that's this 25 here. 25 shots were taken by females and were hits. That's 25 out of 134. So there's the and probability. An or probability. This is the symbol that we use for the or probability, the probability of hitting the basket or the shot was taken by a female. This right side up U represents union. So we're uniting all of the events where we had a hit or the shot was taken by a female. And if we look in the middle of the table, not in the margins, which are in gray, but if we look in the middle of the table, these are the outcomes that we counted up when we actually were shooting paperwads in class. It's these three values that we want to include, the 21, the 25, and the 49. All three of those values in any one of those cells. This 21 represents hits. Now, they're taken by males, but I don't care about that. I want to count any event that was either a hit or it was shot by a female. So this would count because those are hits. Here, these 25, they are hits. They also happen to be from females. They have to be at least one or the other. They are. These were shots taken by females. I don't care that they're misses because they satisfy our criteria. They are either hits or were shot by females. These 39 are the only ones we don't want to include. Those were taken by males, and those are misses. So the 21, the 25, and the 49, if we add those up, that gives us our probability of 95 out of 134. So the last type of probability that I want you to consider is a conditional probability. So take a look here. The probability of hitting the basket given that the shooter was male. That word given is often represented by this vertical bar. So the probability of a hit given that the shooter was male. And what is written on the right side of the bar, that represents the condition, given that the shooter was male. So we are only looking at the events where the shooter was male, and of those events, we're going to look for the hits. So only for where the shooter was male, so I'm only going to look at the male column. So there's a total of 21 shot, rather a total of 60 shots. 21 of those were hits, 21 out of 60. So there's our probability. That condition, given that the shooter was male, that condition effectively changes the denominator. It changes the trials, the total number of trials that we are looking at. This is called a conditional probability. Now, if you compare 6 and 7, notice that in 7, the condition for question number 6 is now the probability that I'm trying to find in question number 7. I'm interested in the probability that the shot was taken by a male, given, though, that I'm only looking at hits. So if I write this, I'm interested in the event that the shot was taken by a male, but the condition is I'm only allowed to look at the hits. So the reason I wanted you to calculate this probability is I wanted you to realize that the order matters. The probability of a hit, given that the shot was taken by a male, is not necessarily the same as the probability that the shot was taken by a male, given that it was a hit. So here, we only are allowed to look at the hit row, and I'm interested in the events where the shot was taken by a male. So here is the hit row. These were the shots that were taken by a male. Those 21 out of 46. That's this conditional probability. So notice what's really important here is the condition affects the denominator. The probabilities in 6 and 7 are not the same. They have different denominators. So order matters. Order matters when you are calculating conditional probabilities. Let's look now at one of the ways that we can make a decision by using probabilities, or essentially by comparing. So events are independent if one event does not have an impact on the probability of another event. So let's consider the events hitting the basket and the shooter being a female. So if these events are independent, then the probability of hitting the basket should not change. It should not depend upon whether the paperwad shot was taken by a female or not. So let's take a look, before we look at third period's data, let's look at second period's data. So this is second period's data. So here we go. For second period, the probability of a hit, there were a total of 59 hits out of 177 shots. Second period. 59 hits out of 177 paperwad shots. No problem. So now let's see if the condition that the paperwad shooter was female, let's see if that condition has any effect on the probability of a hit. So given that the paperwad shooter was a female, so looking only at the female column, let's look at what the probability of a hit is. So here's the female column. There were 32 hits out of 105 paperwad shots taken by females. So 32 out of 105, that's about 30.5%. And this symbol is the approximately symbol. Just out of habit, I tend to round my probabilities to 3 decimal places. 2 would be sufficient, but I want a little bit more information here. So to be independent, the event that the paperwad shooter was female, that should not affect the probability of the event that the paperwad shot is a hit. Well, notice there is an effect, because the condition that the shooter was female actually lowers the probability of a hit. Now, it doesn't lower it by a whole lot, but it lowers it enough where if I saw that a female was about to take a paperwad shot in my second period class, something, of course, that happens all of the time, but if I had information that the shot was going to be taken by a female, I might lower my expectation. In other words, I might lower my expectation that they hit the basket, because that information, the fact that the shooter was female, might affect my decision, because when I look only at the females, the likelihood of a hit is lower. So that condition, if that affects the likelihood of the probability, if it lowers it or if it raises it, then the events are not independent. So in other words, the probability of a hit depends on whether the shot was taken by a female. If the paperwad shot is taken by a female, I can see that the probability is lower. So the way that we would describe this comparison, the events hit the basket and the paperwad shot being taken by a female, they are not independent, because I can see here that being female, it lowers the probability of hitting the basket. So that's what happened second period. But that's not always what happens. So you never know what you're going to get. So let's find again the probability of a hit for third period's data. So here's third period's data. There were 46 hits out of 134 paperwad shots that were taken. So 46 out of 134. Let's go ahead and again, we'll do that to 3 decimal places. So that's approximately 0.343. So now let's look only at the females. So looking only at the females, the likelihood of a hit is 25 out of 74. All right, well, 25 out of 74, that probability is 0.338. Strictly speaking, this is for third period's data. So notice, strictly speaking, these two probabilities are not identical. So independence is defined in this class in AP Statistics. Independence is defined based on probabilities. So the truth is, you don't need to tell a story in order to decide or in order to explain whether you think events are independent or not. It doesn't matter whether you think that gender should affect the likelihood of a hit. We're using the data and the probabilities in order to make a decision about the relationship between those two events. So strictly speaking, the event, again, for period 3's data here, the event that the paperwad shot was taken by a female, does it affect the probability of a hit? It ever so slightly lowers the probability of a hit ever so slightly. So the truth is, strictly speaking, if you wanted to answer this question, I would offer that these events are not independent. Again, that's because the event female, it lowers the probability of a hit. Now, for practical purposes, look, either way, those probabilities are very, very close. They're both about 34%. They're both about 0.34. I know they are not exactly the same, but for practical purposes, they really are very, very close. How close is close enough? That's something that eventually we will talk about in this unit. But look, just for the sake of comparison, I'm going to write this answer a little bit differently. So let's round to 2 decimal places. We'll round conveniently. So I say that because now the probability of a hit is 34%, and the probability of a hit, given that the paperwad shooter was female, is also 0.34 if we round conveniently to 2 decimal places. So for the sake of comparison, if you have 2 probabilities that are identical, well, what you can say here is, based on that comparison, the event female did not affect the probability of a hit, but that's specifically for 3rd period. This is not what happened with 2nd period students. This is what happened with 3rd period students. So in this context, when I compare these two, I'm inclined to say that these two are independent because the event that the paperwad shooter was female doesn't change. It doesn't have an impact on the likelihood or the probability of a hit. So I'm saying this as a basis for comparison. So by that, let's look again at 2nd period. So here, for 2nd period's data, I can see that there is a difference in those 2 probabilities. So given that the shot was taken by a female, the probability of a hit has been lowered. So for 2nd period's data, I would not say that these are independent. Being female lowers the probability of hitting the basket. So, and again, strictly speaking, for 3rd period's data, the probability is ever so slightly lower. So if you wanted to say that these are not independent because the probability is lower when the shot is taken by a female, I can accept that. But also, because if you round both of these to the nearest hundredth, they're both the same. I can understand for practical purposes, especially we're just talking about shooting paperwads. For practical purposes, you could argue that these are independent of one another. The event that the shooter was female really doesn't affect the probability of a hit. So strictly speaking, to be independent, they need to be identical, but these are pretty darn close, and I would offer in this context, this is not a life or death context here, this is a context just for fun. The truth is, in my 3rd period class, it doesn't matter whether someone's shooting a paperwad or I know that the shooter is female, I would say the chance of hitting the basket either way is 34%. Knowing that a female is going to take the shot would not impact my decision. I would say that the chance of making a hit is basically 34% or around a third, either way. So I wanted to compare 2 different examples of independence. This one was a little bit more interesting than I expected. So I hope this was helpful.